Today we are going to demonstrate a tool called PyGress, an automated code competency analysis system that analyzes competency by examining their GitHub code contributions. This tool uses advanced code analysis to assess programming skills using international CEFR standards. The system takes a GitHub repository URL as input, like any public GitHub repository containing Python code, and then click Generate button to proceed the analyzing process.
After inputting the GitHub repository URL, it's time for the PyGress tool in the backend process. What PyGress can do in the processing step is classifying code changes from the commit level into a competency score, grouping code changes, and visualizing the competency score in a graph for better analysis. Next, please. Before knowing the in-depth processing step in PyGress, this is the concept of CEFR and competency score, which is the core concept of the PyGress tool. In CFR level, similar to English, we can also assess the competency of developers based on the Python code that they wrote by using a library called PyCipher. PyCipher helps to determine the competency of Python developers with the same level format as CFR or from A1 to C2. From the table, each Python code construct has its competency level similar to CFR criteria, and the competency score is the list of gathered scores A1 to C2 as a record. Next, this is the overall process of our analysis, which is divided into three main parts. After we input the GitHub repository from the Python project, the analysis will first extract the list of commits from that project. That dip into the commit A. Commit A is classified into two files, which are the source codes before and after the commits separately. In the next step of analysis, we integrated the PyCipher tool to analyze the competency scores by assigning the level A1 to C2 to the code constructs on files before and after the commit. Then, we aggregate both competency scores by subtracting the competency scores after and before the commit to find the differences in the competency score of that commit. In other words, the result from the aggregation is the competency score of code changes in that commit. Before the last step, the list of competency scores of the added code from each commit profile is recorded, and lastly, the list of competency score is used for visualizing. Next.
Okay, after entering a GitHub repository URL and generate, the output includes two parts, which are the overall competency form of the commit and the individual competency of each developer. Each part contains one spider chart and one slider graph, as you can see in the interface. The spider chart shows the distribution of code competency levels. Each asset represents our CFR level or A1 to C2. And the shaded area shows the percentage of code written at each level. And for the slider graph, this graph tracks how competency changes over the time. The x-axis represents the timeline by year and month, and the y-axis shows the competency level. Each bubble represents one commit, and the bubble color shows the skill of level, and the bubble size shows how much code we add in the level. This visualization shows how coding skills change over time for the whole project or each contributor. This all as our presentation. Thank you.